So we go ahead and do this for a simple f of xy, okay? F of xy equal x squared plus 2y squared. It's a paraboloid. And somebody said, well, it is an elliptical. Yeah, it's an elliptical paraboloid, so that was good. That's your modifier. But, you know, the general idea is it has this shape, and it's a little wider in this direction than, in this direction than this direction, if that's the x direction. Okay, so let's say we want to find the tangent plane at the point 1, 2. How do we do that? Well, we find the normal, okay? How do we find the normal? Well, we take this partial derivative, we get our two vectors in the plane, and then we take their cross product. Find a point on the graph. Now, that might be the first thing we do. We just plug 1, 2 in, and we get the value of f of xy. And in this case, that's going to be 9, I believe. So we have the point 1, 2, 9. Once we have the normal vector in the point 1, 2, 9, we just find the plane through the point with that normal. And we know how to do that. Okay. So, well, our x partial derivative is 2x. Evaluated at 1, 2, x is 1. There's no y involved in fx, so we just get 2. And you can easily verify that fy of 1, 2 is 8. Fy is 4y, and y is 2, so 4 times 2 is 8. Okay? Now, I did unit tangents again, which was unnecessary to unitize them, but I did it. And I did their cross product. Okay, now I did the cross product, I didn't do a determinant. I used the distributive law, because you have a distributive law of cross product over addition of vectors. Okay, so you have I cross j, there it is, and you have I cross 8k, there it is, and you have 2k cross j, there it is, and you have 2k cross 8k, which I just wrote as 0 because k is parallel to k, and its cross product with, the cross product is 0. Then I cross j is k. I cross k is negative j. You know, I cross k gives you negative j. So we have a k and we have a negative 8j then. And k cross j, well, k cross j that way, that's the negative x direction. So k cross j is negative I. So the 2k cross j is negative 2i. Now we got that square root of 325 down there, and it's not a unit vector. So as it turns out, I never needed to do anything with these denominators. It didn't work out the way my misguided brain led me without, again, examining my assumption. Okay, that vectors in perpendicular planes are perpendicular to each other. It's clearly not so. Not always so. Better not always be so, because it didn't work this time. Okay. So right here is a perfectly good normal vector. And if we wanted to divide it by the square root of 325, that would be fine. We'd still have a perfectly good normal vector, and we'll still get the equation of our plane. So, the point on our plane is what? It's 1, 2, f of 1, 2, which is 1, 2, 9. Our normal vector is negative 2i minus 8j plus k. So all we have to do is find the equation of the plane through this point, normal to this vector. And that's where we'll go next.